Hey everyone, in this video we'll be talking on quadratic equations and in detail minima and maxima, which are the lowest or the highest points on a curve. Let's start with what a quadratic equation means. Well, it is a polynomial with degree 2. Now, talking about the standard form of the quadratic equation, it is ax squared bx plus c is equal to 0. Sometimes we will write 0, but it would be more mathematically accurate to write y. I prefer writing y. Now, the conditions here are that for this to be a quadratic equation, a can never be 0. Why? Because if a becomes 0, then it's going to be bx plus c is equal to y, which is just a linear equation, not a quadratic equation anymore. Now, the thing here is that a is the coefficient of x squared, b is the coefficient of x raised to the power 1, and c is also the coefficient of x to the power 0, also known as a constant. So let's move on to the graphs because minima and maximum are based on the graphs. Let's take case number 1 when the coefficient of x square, which is a, is greater than 0. It can never be equal to 0, just like we talked on the previous slide. So let's take case number 1, which is where a is greater than 0. Now, for example, this is a coordinate plane. Then the graph is supposed to look something like this. If there exists real zeros, then they will intersect the x-axis. We'll only talk about polynomials or quadratic equations with real zeros right now. So one zero is this, and the other is this. Now, when a is greater than 0, it is an upward opening curve. Upward opening curve. So we do not have a maximum point here because this will go on extending infinitely in the upward direction, in the positive y direction. So we do not have a maximum value, but we do have a minimum value, which is at this specific point. Now, what is this point? Now, from the quadratic formula, we know that x is equal to minus b plus minus under root b square minus 4ac upon 2a. So we can write alpha is equal to minus b. Alpha is one of the roots of the quadratic equation. So alpha is equal to plus under root b square minus 4ac over 2a, and beta is equal to minus b minus under root b square minus 4ac upon 2a. Uh, because that's just the two roots of a quadratic equation. So we just wrote that. Now, the thing is that this point has the coordinates alpha comma 0, and this point has the coordinates beta comma 0. And this point, which is called the minima, or in general, the vertex is either the minima or the maxima of it. So this point will have the coordinates, the x coordinates of minima are alpha plus beta over 2 upon f of alpha plus beta upon 2. Now, why does this happen? We know that when we are plotting the graph of a quadratic equation, the y coordinate is just, for example, if y is equal to x squared, we put x is equal to 2, so we get y is equal to 2 squared, and 4 is equal to actually y is equal to 4. So we get the point as 2 comma 4. So y is just the result of that, putting x into the function. So that is why we have this coordinate. Now when we add alpha plus beta, we get minus b plus under root b square minus 4ac over 2a plus minus b plus, actually it's minus here, under root b square minus 4ac upon 2a. We're only talking about the x coordinate right now. We'll talk about this later. So we get, also yeah, I forgot to divide this by 2. This is divided by 2. Then we get, um, let me write it over here. What we get is, this cancels out. So we get minus 2b over 2a upon 2, uh, and this simplifies to minus b over 2a. This is what we get. So the x coordinate of the minima is minus b by 2a, and we talked that the y coordinate is just the function with the x value in that. So this is the coordinates for the minima. Let me write it clearly over here. Coordinates for minima, minus b over 2a f of minus b over 2a. Now, moving to the next slide. When case number 2, when a is less than 0, so the graph will end up looking something like this. And the zeros are this, this, this. The coordinates of this point will be alpha comma 0. The coordinate of this point will be beta comma 0. And applying the same thing we did, we'll get the coordinates of this point is as let's call this vertex minus b over 2a comma f of minus b comma 2a. These are the coordinates of the point. So that is literally it. We apply the same thing. The coordinates of the vertex, and this is for both minima as well as maxima. The coordinates are going to be minus b over 2a comma f of minus b over 2a. Now we'll
Forgot to
look at.
mention it in the video, but I think this is worth mentioning. This vertex also divides the quadratic equations graph, which is a parabola, into two symmetrical parts. That is something worth noticing. When you learn calculus, the areas will be same of the two symmetrical halves.
at approach number 2. Let's start. The approach is basically on how to get the four basic formula, the vertex form, which if you've ever heard of, or get the coordinates for the vertex. We start with this: ax squared plus bx plus c is equal to y. This is the standard form of a quadratic equation. Now, what I'm going to do here is we're going to isolate the x term, so we can create one single term out of x, and we'll minimize the x term so that the c value, which is the constant, dominates. We'll be trying to isolate the x into a single term so that we can minimize it. So let's take a common here, and we get x squared plus b by ax plus c is equal to y. We wrote b over a, so that just multiplies and becomes bx, which is what the original equation had. So it's a x squared plus b by ax. Now what I'm going to do is I'm going to add b square over 4a square plus c minus b square um, minus b square over 4a square is equal to y. I added this term and I subtracted it, so it makes no change. The net effect is zero, it nullifies. But why did I even add this? The thing is, I'm trying to create a perfect square here, which is going to be x plus b over 2a square. If you try to square this, we will get x squared plus 2 x b over 2a plus b by 2a square with whole square, which is b square by 4a square. This 2 cancels out and we get x square plus b by a plus b square by 4a square, which is what we had here, which is what we want to create here so that we can isolate the x term. So that is why we're doing it. Now, let's write it like this now because we have created a perfect square. We'll take minus common here. and get sorry, b square over 4ac minus c is equal to y. This is what we're going to get. Now moving a bit down, we're going to minimize this, but let's look at two cases again. Case number one, a is greater than 0. So when a is greater than 0, we know that in a x plus b by 2a squared minus b square minus c. Let me just take 4ac common here. We get 4. Oh, my bad. It's not 4ac, it's 4a squared. This is going to be 4a squared. This is going to be 4a squared. My bad. This is going to be 4a squared. We get 4a squared b square minus 4a square c is equal to y. We just took an LCM here. Now, the thing is that a is a positive integer, positive real number, in fact, not a positive integer necessarily, but it's an positive real number. And x plus b by 2a square is always positive because this it's either positive or zero. The lowest possible value of this is zero. So we are going to have to minimize when a is greater than zero. You can see the graph. We have a minimum value here. We do not have a maximum value. So to minimize this, we have to put the lowest value of this is going to be zero. It cannot be more less than zero because it's a square term. So we're going to have to put uh, x plus b by 2a is equal to 0, and out of that we're going to get x is equal to minus b by 2a. So when we put this in that, if you go back in the video and see the previous slides, you will notice that this is what we had gotten from the quadratic equation derivation. Now, when we put this in the equation, f of minus b by 2a, we get this is f of x, a minus b by 2a plus b by 2a squared minus b square minus 4a square c upon 4a square is equal to y. Uh, this cancels out, so we get minus b square minus 4a square c upon 4a square is equal to y. To be honest, you can just write this as b squared by 4a squared minus c. Like this, there's no problem. And you can just open the bracket and get c minus b square minus 4a square is equal to y. Now, the thing that comes is that y in this case is always going to be greater than or equal to c, because obviously um, this term will always be positive, and when you add something to the c already, then we get y greater than it, and if we do add 0, which is the lowest possible value, then we just get this term as it is. So that is what happens. So that is for that is the explanation when a is greater than 0. Now moving to case number 2. Case 2, a is less than 0. The graph is going to looks like this, and the coordinates will be alpha comma 0, beta comma 0, and the maximum point, we'll have a maximum point over here, no minimum point. Maximum point, or in general vertex. So we'll use the same thing, the same approach, but the thing is that when we write a, x plus b by 2a whole squared uh, plus c minus b square by 4a square is equal to y. When we write this, this term is going to be negative always. Why? Because this term x plus b by 2a whole square is going to be positive at all times when real roots exist for the quadratic equation, and a is always going to be negative. So this will in turn become a negative term. Uh, a x plus b by 2a square will be negative when a is less than 0. So we'll just, to minimize this, we'll just use the same thing. We'll put minus b by 2a. Also, the lowest possible value of it is 0. We can, it cannot be until, fuck. The lowest possible value of this is going to be 0 when x plus b by 2a whole squared becomes 0, because we know a can never become 0. So this will always be greater than, sorry, less than or equal to 0. So we'll get the x coordinate for the vertex as minus b by 2a, and is going to be f of minus b by 2a, same as the previous case. But a difference that is going to come is, in this case, y is going to be less than or equal to c. Why? Because in y we'll always be adding a negative term, or we'll be adding 0. So when we add a negative term, it's going to be less than. By the way, when I say c, I mean this entire thing, not just this, but this entire thing. So that is going to be always less than or equal to c. Why? When we add a negative term, it's going to be less than c. But when we add 0, it's going to be equal to c. So that is the derivation for the entire thing. Now, some key points I'd like to add are that the vertex form of a quadratic equation is y is equal to a x minus h whole squared. It is a x minus h whole squared plus k. I'll write some stuff. Here h is equal to minus b by 2a, because when we write minus b by 2a, it's going to be minus minus and it's going to become plus. So it's going to get x plus b by 2a whole squared, a, and k is equal to c minus b square by 4. So if somebody asks you the vertex, the coordinates of the vertex of any quadratic equation, by the way, in this video we just talked about quadratic equations with real roots. So until 10th grade, you're only going to get quadratic equations with real roots. So uh, we can say that the vertex is going to have the coordinates minus b by 2a and f of minus b by 2a, which is just minus b by 2a and c minus b squared by 4a squared. This is the entire proof and derivation, and this was an intuitive approach and intuitive idea to how it was discovered. Now, if you have any doubts or questions, you can always leave them in the comment section or join my Discord server. I'm always open to answer them.